All right, back to business. All right, so where we are in here. So we need to solve for it. Now, do we have a fraction? Do we have a fraction on the equation? Hello? Do we have a fraction in the equation? My online folks, did I mute myself? No, I didn't. I didn't mute myself.
Yeah, we do.
What? Oh, yeah, yes, we have a fraction. So what is the least common multiple for the denominators here? If you have a fraction, what is the least common multiple for the denominators? Yes, only 3, because 16 has a fraction which is hidden 16 over 1. The least common multiple for 1 and 3 is 3. So we're going to times both sides by 3. So if I do that, so minus 48 is equal to 2x, isn't it? Are you saying that? Now you should know what to do. You absolutely know what to do after that. All right, guys. So we are going to moving back to this worksheet. So you got this worksheet. You got this. You can pass this. And then if you get this worksheet, there's another things come. What is linear relation? All right. So this is for you, lady. Let me stay focused. Oh yeah, you can pass that. All right. Okay, guys. So we're gonna moving back to a new topic. If you have any still questions on this, I will come back. So this is going to be. You can only teach us biology and chemistry. You're not confident in math. Did you?
I mean, it's grade 9.
Grade 9, okay. Because now, I don't have a time slot at all. My classes for September is packed. But people are calling it.
Right.
I don't want to kill myself.
Right.
So I try to see, I need especially for math. I don't know where my time is going to come from. All right. So where we are, what is linear relations? All right. All right. So you guys going to get this handout. You know what? That's going to become, oh yes, so save to files. So save to files. Save. All right. So today we're going to continue. So last class we talked about some patterns, how to describe patterns on, rates. Right? We talk about rates. So insert this handout PDF. And then it's still loading in here. Okay. Oh, recent files. Cool. Do you guys know Staples sell stationery more expensive than Walmart for the same item?
Yes, Staples is expensive now.
Yes. So a pack of these pens, it's $1.99 in Walmart. Staples sell the same one for $3.89. All right. We're gonna going back to linear relations. Now, you should have learned linear relations in grade 8. But what we do in grade 9, we reintroduce what the linear relation is. The linear relation is a nightmare for most of the grade 9s. And you guys are going to see why when we go by. You still going to be work with linear relation in grade 10. You cannot excuse with that. There's no way to escape. You're going to see in grade 10 is going to be laughing at you in the first chapter, right? But what is linear relation? So we talk about last class relations. We talk about how to compare relations, right? We got a table of values. But a linear relation is basically a relationship between two pair of coordinates, x and y, increasing by a fixed amount. We call this constant rate. So let's look at this example. A linear relation has a constant rate of change. And the graph of that relation will be a straight line. Now they call this first difference is equal. So let's talk about each one of them in the graph. So you see the first one, is it a straight line? The graph is a straight line. If you find a graph between two variable x and y is a straight line, you can close your eyes and say linear relation. Now let's look at the table of values. In the table of values here, let's see by how much the y increase each time. By how much is increasing this time? 5 to 7, increasing by 2, isn't it? 7 to 10 increasing by 10 to 14 increasing by plus 5, isn't it? So the y values, we talk about it, they are dependent variables, not increasing by a fixed amount, isn't it? So non-linear relation. So now I'm going back to my online folks. So let's ask Vaishali online. Vaishali online, why do you think, oh yes, the answer was here, there's no point I'm asking you. So you guys can see it's a curve, and this curve is non-linear relation. Now the last one, it's basically says a linear relation, but the question is why? The reason they say equal first difference. The question is what is first difference? So we're gonna see what is first difference. The first difference is simply, you need to calculate the difference between adjacent y values. You guys gonna calculate the difference between the adjacent y values. So how do we do that? We're gonna subtract -1 minus -3. So what is -1 minus -3 is equal to? Tavan, are you online, Tavan? Tavan?
Yeah.
Okay, what is -1 minus -3 is equal to?
-1 minus what?
Mm-hmm. How much?
-1 minus -1.
-1 minus -3, how much?
It's 2.
Thank you, sir. All right. Are you following that as 2? So if you guys get confused, what you have to do, roll the number line. So where do we start from? We start from -1, isn't it? Then we see 2 minus signs, minus and minus. So that means minus means go to the left side. The other minus, they go to this way. So how many unit? 3 unit, isn't it? So 1, 2, 3 unit. You know, we're gonna end up with 2, isn't it? Okay, cool. Now, 1 minus -1, which is 2. 3 minus 1. 5 minus 3, which is also 2, isn't it? So this is called the first difference. Did you guys see how I calculate the first difference? Is everyone saying that? Yes? Hello? Okay.
Yeah.
Now we're going back to state the starting value for each relationship. So starting value where the graph begins. The first one started 0. Second one started 5. When x is 0, it's 5. The next one started 2. The other one started -3. You can see the picture? Starting value. Everyone see the starting value? Starting value, starting value, starting value, starting value. Okay, cool. Now, word description. A hot air balloon starts 5 meters above the ground and rises at a rate of 2 meters per second. So let's look at a graph. So it's begin at 5 meters, and every second is going by 2 meters. So that means after the first second, it should go to 7. Does it go to 7? Yes, it does. After the end of the 1 more second, it should go to 9. So everyone see the pattern? So everyone happy with the graph? Straight line? Now the end of the one, table of values. So if you got table of values, it's the same question, table of values. Is a balloon. You can say start at 5 and going by 1, 2 by each time, isn't it? All right. But sometimes the rate of change can be negative. So let's look at this. We'll start with $200 in his bank account. He spent $20 every week. So he's spending $20, isn't it? Then we're going back to find the differences here, guys. Same thing we did it. So how do we find the differences? The first difference is we need to find the difference between two adjacent values, isn't it? So how do I find the difference between two values? 180 minus 200. So how much I will get? Negative 20. 160 minus 180. Negative 20. Did you guys see? right? All right. So what's things to remember here? Rate of change can be positive or negative. So rate of change can be positive or negative. This is the important key, right? So rate of change can be positive or negative. And the next thing is linear relations. Linear relations produce straight line. Produce straight line graph. Straight line graph and have constant rate of change. Constant rate of change. Make sense? And have constant rate of change. So for a second. All right. So we need to do some practice questions. So that's then coming from the handout. You guys all got the handout. Now I need to go back to the handout, check your understanding. Closer look at the rate of change. No, it's not rate of change. Linear relations. All right, so save to file. So I'm gonna insert that here. Insert. Reason. All right. So we're gonna do some practice with the linear relations. All right. All right, guys. I want you guys to do number 3. You guys go to number 3A and number 3E. Use the first difference to classify whether they are linear or non-linear. So my online folks, you need to create a table on the Jamboard to do the work. My in-person folks can do that on your handout or just do that on your notebook. All right, so now I need to check these guys' work here to see if the calculator is correct. I know that with the projector, I can make it turn on the lights. You know what? Let me open up these windows. I'm not sure if that helps. Can we proceed the projector? Some people. Oh, yeah. Okay. Okay, so once you get here. Okay, that's correct. That calculation is not right, ladies. So we're using -7 minus 5 minus 7 plus 5. Yes. Let's see how you're doing the calculation. What's happening? Okay, that's correct. Okay, that's linear. Okay, so next one, your math is not right. The math is for the second one is not right. So you need to subtract. So you need to subtract this value from this value, isn't it? So that's basically -7 minus 5, isn't it? Which is -7 plus 5. How much is that? Yes, negative what? That's right. And then you need to do that for the other ones, right? Okay. Well, if you guys find that integer subtraction is difficult, I can't help with that, so unfortunately. You need to be careful. All right, so let's go back to my online folks to take a turn to ask questions. All right, where are you guys? Okay, Taman, what do you get for the first one, sir? Linear or non-linear? Taman?
I don't really understand.
Sorry?
I didn't really understand. Like,
Okay, so let's do that, sir. All we need to do is, we're gonna find the difference between the y value. So this is x and y. So 8 minus 2,
I can't see your screen.
which is 6, isn't it?
Your screen's
And I
not.
do 14 minus 8. Make sense?
Your screen's not showing for me.
Oh, no. Okay, my screen is not being shared. Okay, I don't know what happened. Well, let's go back to share screen. Start broadcast. Okay. So here we go. All right, so let's do that again. So we need to find the difference between the adjacent values. So we're gonna do 8 minus 2. 8 minus 2 is 6. 14 minus 8, which is also 6. 20 minus 14, which is 6. 26 minus 20, which is 6. Do you see that?
Yeah.
Okay, so that's basically tells the first difference is constant, so it's linear, isn't it? So they said use the first difference. So the first difference are all equal, so we can say linear. Make sense?
Oh yeah, I understand.
Okay, so now let's go to E. Before I do it, I'm gonna ask Vaishali online. Is that E is linear relation or non-linear relation?
It's a non-linear relation.
Non-linear relation. Now I'm gonna be going back to Nishal to answer that. Why do you think Nishal is not linear? Nishal?
Hello?
Yeah, why do you think it's non-linear? Tinging. Akshaya online. Why do you think Akshaya that is non-linear? Akshaya,
Yeah,
why do you think that's non-linear?
because
It's all about first difference. Did you guys calculate the first difference? Did you calculate by taking the difference between two adjacent y values? -7 minus 5 is going to be -2, isn't it? -1 minus 7 is going to be +6, isn't it? 13 minus -1 is going to be 14. 35 minus 13. So 2, 22, isn't it? What's up? Which one I didn't do correct? -7 minus 1 -2. -1 minus 1, 13 minus 1, 14. 35 minus 13, 22. Which one?
Oh, I thought it was,
Which one?
it was 13. And
13 minus -1.
Yeah, I thought it said positive.
I did review about integers, right? We started with integers. So that's nonlinear relation, isn't it? So non-linear. Are you guys following that? How do we do this? Guys. Hello,
Yeah.
Yeah.
Taban?
Yeah.
Yeah.
Taban, tell me what is the starting value of the first curve, sir? What is the starting value of the first curve?
For A or B?
A.
9.
Thank you. Akshara, what is the starting value of the curve B? I'm talking about B. So starting value, you should not look at the X value. You need to look at the Y value. 16. All right, Akshaya, what is the starting value for curve C?
23.
Well, I think that is going to be 22. So, but that's okay. So 22, 23. All right. So now I want to do one more word problem. So let's going back to the easiest one. You guys going to do number 6. Can you guys look at the question number 6? I'll be back. And then you can check how they do number 6. All right. So the square table, 4 people can be seated. So when 2 people join together, so and so and so, complete the table. All right. Are you guys done? Still filling on the table?
Almost.
Almost done. Okay.
I'm done.
Who's that?
Vishali.
Why, Sally? All right. Complete the table. This. Okay. So do you think Vaishali? You know what? I'm gonna wait for you. I'm gonna wait. So I ask somebody else. Tavan, are you here? Tavan?
Yeah.
Okay. Is it a linear relation or non-linear relation, sir?
Non-linear.
Non-linear. All right. So you fill out the table. So what's the second number? What's the second value here, Dave? 6. What do you think the third one? Third one, what did you get, sir, Tavan?
8.
You got 8. All right. Then 4 is 10, and then 5 is 12. Yes? Right?
Yeah.
Number of seats are going by 2. If I get the first difference, let's do that again. If I get the first difference, did I get this number same? Did I get
Oh.
the same difference?
Oh, I think I mixed up the numbers.
You messed up with the numbers. Okay, sir. Complete the table. Does this example display linear growth? The answer is yes. If 12 tables were joined together, how many people could be seated? Well, that's an interesting question. If 12 tables were joined together, so this is 5, isn't it? So now we need to go back to expanding this. Who answers C? You answer C. How much? You got 26. You got 26. How did you get the answer? You multiply 2. So where is the 26 coming from? You multiply 2 by. You multiply 2 by. You get the 26 by multiplying. How do you get 26?
12 times 2 plus
You did 12 times 2 plus 2. You said 12 times 2 plus 2. Why did you do that?
I did like S as like the number of table. And then, like, 2 plus 2.
Okay. Let's go back to my online folks. What did you guys get? If 12 tables were joined together, how many people could be seated?
28.
28. What are you guys doing? All right, let's do it a longer way. 6 table. How many seats? Huh? 14. 7. 16. 8. 18. 9. 20. 10. 11. 12. 26 is the right answer. Isn't it? What is the difficult part here? What is the difficult part? What is the difficult part here? Nothing difficult? Creating a table. What if I ask how many seats will be in a 30 seats? Or 30 table, what you guys gonna do? Are you guys gonna keep on extending? No. So how we can answer this question? That's the question. So we need to look at for some pattern. So if you look at the pattern, what we're gonna do, this is called, we know it goes by what? 2 each time, isn't it? So for a linear pattern, if you see a linear pattern, the pattern rule goes by like this. The pattern rule. So pattern rule. Pattern rule. The pattern rule says 0th term. 0th term plus term number term number times it by the growth rate. Growth rate. This is called the pattern rule. Now, we got the first term, but I don't know the zeroth term. Do you know the zeroth term? No, we don't. We only got the first term. But do we know by how much it's going each time? It's going by 2, isn't it? So how do I get the zeroth term? I need to subtract 2 to get the zeroth term. Because if it goes by 2, if it go up, it should be 2, isn't it? So zeroth term is what? 2. Term number. So called number of table. So the term number here, T. Number of table is X. Number of seats is Y. So term number is going to be X. The growth rate is 2, isn't it? It's going by 2 each time. So this is going to be Y. So what is Y is equal to? 2X plus 2. Now X is 12. Your answer is right. 26. You guys got that? Are you just following that? Yes?
Yeah.
All right. So all you need to do is you need to do zeroth term. If you know the zeroth term, you can find the rule. All right. The rest is your homework on this. Rest is your homework. So linear relation. What is linear relation? Okay. Now we're going to talking about a rate of change. I want to pass this. Somehow it's printing one side. Is it one side? I think it's one side. Okay. Only one side, one side. You got one? You didn't get one. Okay. There's only one side, the rate of change. But let's look at a rate of change. That's 2 page. Yeah. Different, and then you got this. Okay, cool. All right, guys, so I'm gonna going back to introducing the next annoying concept. All right, that's for you, sir. So they will be doing the homework on this, so you can take that to Queens. When you're leaving?
This
This
Monday,
week?
I guess, yeah, this
Oh, this Monday you're packing up to start your journey for another 2 years? Is it 2 years or 1 year?
It's 2 years.
2 years.
Yeah.
Do you have to do any co-op?
Yeah, I'm like doing a TA, not like actual.
Oh, yes, TA. TA for physiology related subject.
Like, yeah, health and nutrition course.
Do you get a free tuition fee or?
No, but I have like stipends, so it's covered.
Oh, yeah, for the teaching assistant.
It's like for even the research, like they get,
Oh, you're doing a research work too?
Yeah.
Oh, that's not bad. How much they paying Stephen?
21,000 per year.
Oh, wow, that's, you need to do a little more work for 21,000.
Well, it's like 9,000 of it comes from TA. TA.
Yeah, TA, and then so altogether 21,000. But you will be basically get paid minimum wage the amount of work you get.
Yeah, yes, very much so.
All right, so let's go. All right, so where we are. All right, closer look at a rate of change. Closer look at a rate of change. That's what the lesson is about. All right, so this is the continuity of this lesson. So you guys need to do this as your homework. So this is going to be August 28th lesson. And what I want to call this rate of change. All right, so let me insert this file. All right, the next topic is how we can calculate the growth. So the rate of change of a linear relation is calculated by dividing the change in the independent variable, which is y, by change in independent variable x. So let's going back to simple example. So look at the temperature. The temperature basically decreasing, isn't it? Over the time. So you can see by time is increasing by a fixed amount, 2 minutes. So how do they calculate the rate of change? Change in temperature by change in time. So how they can do that? There's several ways people divide this. Change in temperature, it's changing by -30, isn't it? Each time. But how far it's changing it? Every 2 minutes. So what they did, they take the difference in y value divided by difference in x value, -30 divided by 2, -15. Did you guys see that? Right? Makes sense? Now let me going back to something here. You can also do it a little differently. Let me choose 2 points here. I'm going to highlight it. I'm going to choose this point and this point. Did you guys see that I highlight those 2 points? Look at the points I highlighted. Now let's do the change in between these two. So change in between these two means 70 minus 160. So that's a change in dependent variable. And then what's the difference between these two? So I choose 70 first. 8 minus 2, isn't it? What is 70 minus 160? Negative 9. Is it 90? 90. Negative 90 divided by, not negative 90. Yes, negative 90 divided by 6, negative 15. And then important that unit. Fahrenheit per minute. Did you guys see the picture? Did you guys see the picture? How do I calculate the rate of change? All you needed 2 points. So let's go back to this example. So rate of change they calculated here. You can see you need to find a change in. So let's look at this coordinate. So let's ask Akshara in person. What is this coordinate? The one dot. Can you read the coordinate? The one marked. So let's mark this 8, this mark B. What's the coordinate of 8? Coordinate, you read that x value first, then y value. Sorry? You say, yes, the coordinate of 8, the one I labeling. Lady, A, what is the A? This point, what's the coordinate? Huh? I said you need to tell the x coordinate first, followed by the y. What is the x coordinate? Yes, that's 4. Then you're going to tell the y. So 4, 100, isn't it? Okay, you're going to tell me what is the y coordinate? I mean B. I said you need to tell the x first. Where did you get 12 from? If you do dot, what is this line? Do we have 2 points? Okay, now let's highlight the x value. To find a rate of change, they got 60 by finding the difference between 160 minus 100, isn't it? You can see that? So that is change in the distance, which is 60, divided by change in time, which is basically 8 minus 4, which is 4, isn't it? Let's do that, 8 minus 4. Are you seeing that? Do you see how they calculate the rate of change here? Vaishali in person online, Akshara, Pavan.
Yeah.
All right. Now let's going back to another one, word problem. The height of an elevator is increased by 20 feet every 5 seconds. That's easy. The change in height is 20 feet. 5 seconds, you divide it by 5, right? And Hammond Preet spends $35 on food every 7 days. So per day, she's spending an average $5, isn't it? Are you seeing that? All right, so I'm going to give my example. So we can put this time spent increase in marks. It's minutes. This is percentage. Can you guys find the rate of change, please? Find the rate of change. That should be for Albert Einstein, by the way. That should be for Albert Einstein. The time spent and increase in Mars. Time spent in studying. All right, what did you guys get? You got 2.5. Who got 2.5? Taban, what did you get? Taban? He's here in the class. Akshaya, what do you get?
I'm still
Akshaya?
working on it.
Okay, so moving back to Nishal. Nishal, what do you get?
I'm still working on it too.
Come on, guys. I'm bored. Okay, you got 2.5. I don't know if that's right. We'll see. Let's see what she's doing. Say 25 minus 15, correct, okay. Okay, and then you do, that's minus, why do you do 5? Where did you get a 5 from? Oh, it's okay. You got it right, so let's do the calculation, that's right. Didn't get a cover yet? Then you divide over on
Well, yeah, I've ordered it.
Okay, yeah, you can get a cheaper one in Amazon.
Yeah.
Like this one is, I bought it for keyboard. So especially when the school starts that, I just walk around with that. Yeah. So I go to school to set up my classroom, but I'll be disappointed if my principal installed a whiteboard, which he promised.
If they don't, or
If they don't,
don't.
because my blackboards are so old. So if I write it, people can't see it. So I'll be really, really pissed off if there's no whiteboard there. All right, guys. Nishal, what did you get?
I'm almost done.
What is more expensive? Hiring moving people.
Or for the.
They're making a big bucks.
Yeah. What for what? To change your classification.
No. Moving myself, so I'm moving to Pickering.
Like your like house.
Yeah,
Oh yeah.
so expensive.
Really? Yeah. I mean.
They charge. They charging like. So I got several quote.
Mhm.
The minimum I got is $80 per hour, bringing 2 people in. But there are people charging $100 per hour.
I mean, it's kind of hard to move stuff. You're paying them for a reason. It's only
Yes.
one time.
Well, no, in one guy, just bring 2 people, but the hourly wage is just $40, $50 per hour. Hopefully that, yes, sir.
Oh.
Like I say, $80 per hour, the minimum I got. It's a teacher discount. He bring 2 people, but I pay for his truck. That's the additional cost. The other one I got $180 per hour. He bring 3 people. But I know how the 3 people will be efficient when they come inside the home, try to move things. What do you think, guys? Hiring 3 people with $180 the best, or hiring 2 people for $80 is the best? Do you think that 3 people will move things faster when you're moving? Right? Technically speaking, it looks like more manpower, but hypothetically speaking, one person will move slower, other person will blocking in, so they're getting extra pay. But 2 people can get the job done faster. Okay, what did you guys got? You got it done. What do you got? Okay, I got these guys got 5. These guys get 5. My in-person guys get 5. What did you guys get? Online folks. Akshaya.
I got
Akshaya, what did
5.
you get? What?
5.
Okay, and then
I got
then
5.
You got 5 too?
Yeah.
And then how about Vaishali online? Vaishali? You got 5 too?
Yeah,
Hello? You got 5?
yeah.
Okay, where do you guys do your math? On the Jamboard? Where do you guys do your math?
On the Jamboard.
Let me see the Jamboard to see the math. Okay, I'm curious how that looked like. All right, so this is I have Vaishali online. So on Jamboard, there's. I just want to see how to do this. Okay, this too. That's. So where did you do this? I didn't see your. Huh?
My iPad died, so I had to do it on paper.
All right. So how about the other folks? Where did you guys do your work? Tavan, where did you do your work, sir?
On the Jamboard.
What?
On the Jamboard.
You did on the Jamboard. Okay, so I'm gonna go and make your Jamboard, sir. Whose Jamboard is this? Dismiss. Which Jamboard, sir?
It was August 28th one.
August 28th. I'm in August 28th Jamboard. So this is August 28th lesson. Where? Where did you do it?
It's showing on my screen.
It's showing on your screen. Okay. So you guys got 5. 5 is not a right answer. So the right answer is 2.5. Let's see how to get that one. I say you can choose any 2 points. You can choose any 2 points. You're gonna find a difference between the x, y values. So how do I find that difference? 25 subtract 15. I took 25 first, so it's gonna be 11 minus 7. So 25 minus 15, 25 minus 15 is 10. 11 minus 7 is 4, is 2.5. So I'm confused. How do you all get 5? Well, my in-person guys got it correct, but I don't want to give the right answer. So I tell you guys 5 is the answer, and you all said it's 5. So what's happened? What's happened? I just said 5, and then you guys all agree with that. The answer is 5. Is that correct? Hello? Okay, they're quiet. Are you guys following how do I get the answer at least? Hello? Hello? Guys? Yeah,
Yes, I'm following. Yes, I'm following.
All right, so I'm gonna give you guys the handout on this, looking at the rate of change. So I'm gonna say save to 5. So it's gonna be iCloud Drive, save.
Will the handout be posted on the Google Classroom?
I will do that, sir. Insert. I'm gonna PDF. Recent. Okay. I'm gonna do that in a moment. So what I want you guys to do right now, we're talking about a rate of change. So where is the calculation of rate of change goes? All right. All right. Can you guys do number 2, everyone? Number 2 on the handout. And then I will post that on the Google Classroom in a moment. Just give me a moment. I'm just gonna get the link, copy this link, and then post that in the Jamboard link so you guys can access this instruction, edit. Edit. So I need to add this link, add an attachment, a link. Where's my link? Insert link. Allow paste. All right. You guys can access the handout that I posted on Google Classroom. You can access the same handout that just Google Classroom. You guys going to do number 2. So when your sister is completing a PhD.
Oh, she's probably in another 2 to 3 years.
What?
Yeah. Oh, because she basically her master's is
Oh, master's continue with the PhD. Yeah.
yeah.
And she liked to study. Did she get paid?
I think she gets a stipend as well. Yeah.
She is. So she doing teaching assistantship.
Yeah. It's also like research work in general. It's like the university's research, right?
So the university pays.
Yeah. If it was like course-based masters, they don't pay you.
Okay. Yeah. Yeah. Who's done? Okay, let me check the right answers. Let me see the question. All right, so this question. So this is correct, but the unit is meter. Okay. Sorry. So the first one is asking which one is independent, dependent, right? So when you get a table of values, this is X, this is Y. The Y is always dependent, X is always independent, right? Because the height changes when the time changes, not the time changes when the height changes. So time decides the height, isn't it? So therefore, time is not controlled by somebody, the height is based on. So this is going to be independent, this is dependent, right? And then now the rest is pretty straightforward, right? You know what to do. All right, let's go back to my folks online. All right, Tavan, what is the independent variable, sir?
The independent variable is time.
Time is the independent. Yes, you're right. That's time. My question is dependent. Okay, and then dependent is going to be the height. All right. By the what values the numbers in the left column increasing? Rishad, I mean, Nishal. By what values the left column hand increasing?
By 5 seconds.
By 5 seconds. That's right. And then by Charlie online, what y values numbers in the right hand column is increasing?
10.
It's a relationship is the relationship is linear or non-linear, Nishal.
Non-linear?
How come, lady? Is that first difference is 10 each time? If you do 10 minus 0, 10, 20 minus 10 is 20 minus 10 is 10, 30 minus 10 is 10. So what made you to think non-linear? Huh? First difference is constant, isn't it? Hello?
Yeah.
Now the next one, growth rate. So to calculate the growth, I say we need 2 points, isn't it? So I can choose 5 and 10, 10 and 20. So 20 minus 10 over 10 minus 5, which is 10 over 5, which is 2 meter per second, isn't it? All right, guys, you guys gonna do this finish your homework. And then some of you might have math this semester, some of you not having a math semester. But regardless of whether you have a math or not, I will say that if you're free on this time, I'm not going to be taking any new people to this class. They can learn from the middle linear relations. So we will keep this class continue to finish your grade 9 steps. So same time, but 6 o'clock. And my folks online, yes, you can really come on in person. I can't really do anything. But I don't really like learning online, especially math. Right? I'm trusting you, you're doing some work on the other side. Right? It is possible to get fooled around too, right? So we will meet next week with the same Zoom link at 6 o'clock, not at 5:30. Make sense? Hello?
Yep.
Yeah.
All right, so the worksheet I posted on the Google Classroom, if you cannot, you can also access from OneNote. Right? All right, guys, and good luck in your first year of school. On